Hello, this is Fabian Reels. This is a video I'm doing on it's basically a game I'm developing. It's called Animutants. Um, when you move the character um, to to the object like a tree, that's supposed to be a tree, by the way. Um, the character stops. If he goes a little further forward, he continues going. It's slowing down, so let me restart it again. I'll give you the example in a second. Hold on. Here we go. The output, when it prompts, it slows down the computer. I have a bunch of stuff being prompted, um, and it's basically slowing down the computer. So, um, some of the collision detection is still not working correctly. It still has a little bit of glitches, but some of it is working fine. So here he's actually stopping on some of the parts of the tree, and as you can see, he's stopping. So it still has a little bit of glitches, but it's like right now there's so much information being prompted on the output of the flash player, so it's slowing it down, but it doesn't slow down like that normally if I get rid of all the outputs that the prompt is giving me through the flash functions that I developed. So anyway, that was a demonstration of a game I'm going to try to develop. It's not completely done yet, but it's going to be three-dimensional, and it's going to be kind of like a RPG kind of over-the-top view kind of game. So I hope you like this. I'm going to show you something next. Hello again, this is Fabian Reels. I'm showing you the next example. Basically, the next example is a math program that I developed. It's not the same as the first one I did on my YouTube channel, but it will be incorporated and integrated to the first math program that I made. Basically, with this one, it's based on a password of one or more answers in the form of a sequence of multiplication table problems that both count down, except the problem, for example, is to multiply the first number by the second number, starting with a number the same as the first number. So why do we do this? Okay. Why do we do this? Why do we do this? I'm going to answer that in a second. Okay, so I'll give you an example. If we are studying the two tables and learn that 2 times 3 equals 6, then we don't have to solve the 3 times 2 problem on the next table of 3's, because it's the same answer. You understand? So we skip from from 3 times 2 to 3 times 3. Okay? Are you getting that? So basically, that's why we do it. We do it that way. So what I'm going to get next to is I'm going to try to read the rest of it. I'm actually reading off of a document here, as you can see. It's kind of encrypted, but we got to that point. So we skip to this. And do you get it? I hope so. So at the end, 12 times 12 is the final answer, because at that point we would have solved all the 12s except for 12 times 12. So that is why I multiply the first number by the second number, starting with a number the same as the first number, and count it down to match its answer on the sequence that is also counted down on the sequence. Okay, so the answers are in a sequence. The answers to the problem is on a sequence. The problem is, I'll give you an example. 5 times 5 is 25. 5 times 6 is 30. 5 times 7 is 35. 5 times 8 is 40. So that's how it goes. You can easily learn, I mean not easily, but you can learn how to do that by counting down both scenarios, which is the second number of the problem, which is like 5 times 5, and count and match it with the answers on the sequence, which is the answer of the problem on a sequence. And you just keep counting down, and you keep counting down, and that's how you memorize it. Well, you can memorize the sequence of answers separately and count them down and match them up, and that's how some people learn it. I know that in school that's what they used to teach me, but I never really graduated or got my GED yet. I'm working on my GED. I'm working on my math, and basically I'm going to give you an example of this program, how it runs. 121, 132. It's going to give you an answer here. Correct, Wing. 11 times count starting with 11. So that's why it said starting with 11. So 11 times 11 is obviously going to be 121. So let's try this out in a calculator. 11 times 11 is 121, like I said. Now, cancel that. 11 times 12 equals 132. You see how the answers are correct? You can go back and look at the video and you'll see that I that's what I wrote down. Now, I guess that's it for now. This has been a Secret Truth video on collision detection and math. If you like this video, please give me a comment or a like if you can. I really appreciate feedback and comments and likes. So, thank you,
and I'll see you the next time.